All right, dears, we're going to be just doing another couple examples of the first and second fundamental theorems of calculus. Specifically, what this is showing is the development of the second fundamental theorem. And so in order to kind of go through this, remember the second fundamental theorem of calculus, what it does is it uses this idea of substitution into whatever the derivative is. So when you're doing the second fundamental theorem of calculus, what you're doing is you are substituting in that bound, that x bound, into the derivative. And so instead of having f prime of t, I'm going to be yielding f prime of x. Okay, assuming that, this is, to find the antiderivative, that's f. All right, so just kind of working through this example. So if I was going to take the antiderivative of t squared, that'll be t cubed over 3, evaluated from 3 to x. So substituting that in, that'll be x to the third over 3 minus 3 to the third over 3, which is 27. 27 divided by 3 is 9. So really this is x to the third over 3 minus 9. Excuse me. And so that's end up going to be that's what we're going to be substituting in for the integral. So really what we're going to put in here is that goes right there. So I have x to the third over 3 minus 9, the derivative. Probably should have used green there. So the derivative of x to the third is 3x squared over 3. So we have x squared, derivative of negative 9 cancels. And so I'm left with this x squared. And so instead of having f prime of t, which I had right here, when I use the second fundamental theorem of calculus, I'm substituting in, and so that is yielding f prime of x. Okay, next example. So if I take the antiderivative of sine, that'll be negative cosine of t, evaluated from x to pi over 2, or pi over 2 to x, sorry. And so substituting in, that'll be negative cosine of x minus negative cosine of pi over 2, which becomes positive. Pi over 2 is 0. So really we're working with negative cosine of x. And so so that's going to be my f of x. And so this guy is stating, hey, I want you to find the derivative of f of x, okay, or f prime of x. Again, remember, this piece right here, sine of t, that is your f prime of t, okay, since t is our independent variable. So substituting in, I get d over dx, so it's taking the derivative of negative cosine of x. Well, that's going to give me sine of x, and you can kind of see that instead of x, now I'm working with the independent variable. Or sorry, instead of the independent variable of t, I'm now working with the independent variable of x. And that's because of this input right here, that x right there. All right, number 3. Taking the antiderivative, I'll get t to the 4th minus t to the 5th, evaluated from x, or 7 to x. And so this will be x to the 4th minus x to the 5th. Subtracted 7 to the 4th minus 7 to the 5th. I really don't care because on the next step, I'm going to be substituting back in. So I'll have the derivative of the previous value. And so since those are constants, I'm going to be kind of derivative of those are going to be 0. So derivative of x to the 4th will be 4x to the 3rd. Derivative of negative x to the 5th will be 5x to the 4th. And then your values go away. Again, you'll notice that your f of t and your f of x are going to look very similar, except for our variable is changing. Alrighty, so let's go to number 4. All right, antiderivative of t cubed, is t to the 4th over 4, evaluated from 5 to x squared. So this becomes x squared to the 4th over 4 minus 5 to the 4th over 4. Well, x squared to the 4th is x to the 8th. And then, this is just a really large value. Don't really care what it is, since I'm going to be substituting it. Alrighty, so here's our dx of our x to the 8th over 4 minus 5 to the 4th over 4. Alrighty, so taking the derivative, I'm going to have 8x to the 7th over 4. And so this will be 2x to the 7th. And that doesn't look like this one right here. So what is going on? And so what ends up happening is our input has changed. You notice how your input is now x squared. And so really what's happening is f prime of x is really f prime of t times the derivative of x with respect to t. All right, so what that will look like is I'm going to, since I'm dealing with f prime of t, really I probably should have written f prime of t being substituted in. So we're substituting in that t, we're going to substitute in x squared. And so my t is raised to the 3rd power, but I'm substituting in x squared. And now I'm going to multiply by whatever I substitute in by, in this case x squared. So if I multiply that by the derivative of x squared, I get 2x. And now I simplify. I get x squared to the 3rd is x to the 6th times 2x. And so that gives me 2x to the 7th. And you'll notice that these values are the same. So what I showed you in the end was kind of a little bit of the shortcut that we're going to be getting to. Alrighty. So for the last one, antiderivative of cosine is sine of t evaluated from pi to x cubed. And so this will be sine of x cubed. Notice that I'm going to have a special value there, minus sine of pi. Well, sine of pi is going to be 0. So my final value is going to be sine of x cubed. So if I take my derivative, I'm taking the derivative of not sine of x, but sine of x cubed. So that means I'm going to have to use the chain rule. So the derivative of my shell, in this case shell is sine, so derivative of the shell is cosine, times my chocolate, x cubed, times the derivative of my chocolate. Well, the derivative of my chocolate is going to be 3x squared. So if I was going to do the shortcut, what's going to happen? So let me see here. So my shortcut way of doing the derivative of the antiderivative, and if you want to think about these are kind of like inverse operations, if you want to think of it that way. So they're going to be canceling each other out. You just need to be really careful because you need to be aware of your input. In this case, my input is at x cubed. And so that's going to be, scooch over here, cosine of my input times the derivative of my input. In this case, it'll be 3x squared. And you can see that I'm getting the same values right there. Okay. All right. Our last one